In this video, I will be explaining the theory of perfect competition. So, I will be speaking about perfect competitive markets. As any theory, this starts with a set of assumptions. To have perfect competition in a market, first, the products are so similar that you can consider they are homogeneous. You can think in a variety of apples or a variety of onions. So that's the first condition. A second condition is that the customers know the nature of the product being sold and the price charged by each firm. And I believe more important to say that the prices reflect supply and demand in the market. So you can see the supply curve, the demand curve, and the price and the quantity interchange in the market is the one determined by the intersection between the supply and demand. If you know supply and demand, you can compute easily what is the price and what is the quantity of the product exchanged in the market. The third condition is that the quantity produced when this long-run average cost is the minimum for each firm is very small relative to the industry's total output. So any firm is producing a small amount compared to the market. And finally, the industry is characterized by freedom of entry and exit. So it will be easy for a firm to go outside of the market. So if at any point the company wants to leave the market, it will be easier for the company, or it will be easy for a new company to go into the market. So this is another condition to be in a perfect competition market. Obviously, there are more conditions, but any other condition can be concluded or can be inferred from these four conditions. So I will be speaking about other conditions in the perfect competitive market, but these other conditions can be concluded from this. So let's start with the study of this perfect competition. If we study the economy in a perfect competitive market, obviously we need to start from the supply and demand curve. And remember, the demand curve will be a negatively sloped curve and the supply will be a positively sloped curve. And the intersection of these two curves will determine the price in the market and the quantity demanded. If this is the case in this market, this price of 4 will be the price of the market, and this quantity will be the quantity demanded in the market. If we study the situation in just one firm, so in a single firm, we are going to have that the price will be 4. So this price, 4, will be the price, doesn't matter how much this company is selling. So the quantity of 60 millions here is the quantity for the whole market. But if the whole market is always selling 60 million, that doesn't mean that this firm will be selling always or producing always the same amount. It's possible that there are coming other firms. Remember, it's possible to come other firms, or some firms can be leaving the market. So the amount of one firm can be moved. For example, if appear a new firm, maybe this firm can be selling less. So the quantity that this firm is selling could be different than the usual quantity. So the quantity can be moving in the demand curve, but the price will have always the same value. We conclude that the demand curve of the firm will be a horizontal line, and the firm is a price taker. So this is another condition of a perfect competitive market. But this condition was concluded, was inferred from the assumption that we have at the beginning. We also know that the total revenue is the total amount received by the firm from the sale of a product. So the total revenue is given by the price of this product multiplied by the quantity. And if we want to compute the average revenue of the firm, So remember that the price was determined by the market. So this price multiplied by the quantity this firm is selling is giving you the total revenue. And the average revenue is always the total revenue divided by the quantity sold. So the average revenue per unit sold will be total revenue divided by the quantity. So we notice here that then the average revenue will be the price times the quantity, making substitution. The total revenue is price times quantity. So the quantity cancel. So we conclude that the average revenue is also the price. So we have then that the price that the firm have taken. So remember now the firm is a price taker. We have a price that it was taken by the firm, and this price is actually the average revenue of the firm. Another concept that we studied here is the marginal revenue. And the marginal revenue is what happened in the sale if we are selling 1 unit more. So the marginal revenue is the change in the total revenue divided by the change in the quantity. If we sell 1 unit more, so the change in the total revenue will be just the price of the new unit sale. It will be the price divided by 1 because the change in the quantity was 1. So you can compute it in this way. So we notice then that the marginal revenue is also equal to the price. So we have that in a perfect competitive market, the marginal revenue, the average revenue, and the price are always the same. You are going to see later that that doesn't happen in a monopoly, for example, or in other type of markets. Markets, when if the company wants to sell more, maybe they need to reduce the price. So the price is not a constant in some markets. Let's see an example that something that could happen in a firm. Assume that we have here this schedule that gives me the relation between the total output and the total revenue. Imagine that the output is 1 and the total revenue is 4. If the output is 2, the total revenue is 8. If the output is 3, the total revenue is 12. If I see this schedule, I notice immediately that we are in a perfect competitive market. Why? Imagine that we want to compute the average revenue, that is the total revenue divided by the quantity. So let's make this in another column, the average revenue. Obviously here we cannot divide by the quantity. This is the total revenue. The quantity is 0, so we cannot divide by 0. But in the second line, here we divide 4 divided by 1, and I notice that is 4. This is 8 divided by 2. This is 4. The 12 divided by 3. This is 4. 16 divided by 4 is 4 again. And we can continue in this way, and we notice that the average revenue is always 4. I know then that the price in this market is 4. And the price that is obviously this company is selling is 4. If I want to compute the marginal revenue, is the change in the total revenue divided by the change in the quantity. If I do this in another column of the table and compute the marginal revenue, and I'm going to put this cell in between 2 cells, because now remember the marginal revenue need to take into account the change in the total revenue divided by the change in the quantity. For example, from here to here, I noticed that the change was 4. From 0 to 4, the change was 4, divided by the change from 0 to 1. 4 divided by 1, because the change from 0 to 1 is 1. 4 divided by 1 is 4. So we know that then that the marginal revenue is 4 here. But here from 4 to 8, when the company is changing the output from 1 to 2, the total revenue is changing from 4 to 8. And from 4 to 8, the change is 4. 4 divided by the change here, 4 divided by 1 is 4 again. So the marginal revenue is again 4. And you notice that always here, the change in the total revenue is 4, from 8 to 12. And the change in the output is 1, in the quantity produced is 1, so it will be 4 again divided by 1, 4. Here will be from 12 to 16 again 4, divided by 1, 4. The change from 60 to 20 is 4, and here the change in the output is 1. 4 divided by 1 again 4, and again here, you can see here that anytime the change in the revenue is 4. So this is a perfect competitive market. The marginal revenue is a constant and is the price in the market, and obviously is the price the company is using. So if we make the graph of this, so we are going to notice that this line here that have always 4, that is a constant, it's a horizontal line. This line will be for the marginal revenue, for the average revenue, and for the price. This is also the demand curve for a firm, for just one firm, because it's telling me the relation between the quantity, the output, and the price. If I want to see the total revenue curve, then we need to take into account the quantity in the x-axis as here, but then will be the total revenue at the y-axis. So that will be different. Yeah? So the curve for the total revenue will have something similar here, the total revenue of the company, and then just take into account this, what is the total revenue. Remember, the total revenue will be always the price multiplied by the quantity. So it will be in any point, it will be changing depending on the quantity then. So here we have the data 0, 4, 8, 12, and the quantity could be 0, 1, 2. So here from 0 is 0, but for when the unit is 1 is 4, etc. It will be a line here. This total revenue is important. You can take it into account to compute the profit. So remember that the total revenue minus the cost will give you the profit. So the total revenue, it will be important for computing this profit. And I'm going to compute the profit maximizing output. The idea of any firm is to maximize their profit. And imagine that we have the total revenue curve. So we have this. If I want to maximize profit, I need to have some information about the total cost. And the total cost will be a curve that we know that will be a U-shaped curve. So it will be something like this. So it's concave up. And it will be a point in this curve in which the difference between the total revenue and the total cost is maximum. So you notice that there are points here when the total cost and the total revenue intersect. So at that point, the profit is 0. Here, for example, again, the total cost and the total revenue is the same. And in the other cases, outside of this sector, you notice that the total cost is bigger than the total revenue. So in these regions, the company is having a loss. And there is a point that will be the point in which these firms will try to work. It will be the profit maximizing output of a perfect competitive firm. So the firm cannot decide what is the price is taken from the market, but the firm at least can decide how many units to produce. So that's what we are going to study now, how the firm decide what is the output for they produce. If we have a perfect competitive market, then the firm can decide only how much to produce. Every firm have the same price, but every firm have different technology. The cost could be different. Okay, so the market determines the equilibrium price. We know that, but the firms picks the quantity of the output that maximizes its own profit. And obviously we know that the profit is total revenue minus total cost, so we need to maximize this. So the distance between the total revenue and the total cost. And this is positive when the total revenue is bigger than the total cost. So in these regions we have an economic loss, and in this region also an economic loss. And we have positive profit in this region, yeah? So we have economic profit at that point. And this maximum appears in just some points of this. So for example, if Q equals 700, if Q equals 700, so we are in this point, notice that the quantity, the output quantity is in 100, and also that the total revenue and the total cost will be also in hundreds. Then we notice when Q equals 700, then the total cost will be an amount here close to 2500, and the total revenue will be around 2800. Then the profit will be 2800 minus 1500, so it will be 1300. So if the company produces this, their profit will be an amount close to 1300. But if the company produces 1100, then we are going to have that the total cost will be around 2600, and a little more than 2,500. Let's see 2,600, around 2,600, and the total revenue will be around 4,400. Then the profit will be 4,400 minus 2,600, so it will be 1,800. So let's find another one. If Q equal 1,000 here, so if this is 1,000, then we notice that it will be around 2,100 the total cost, and the total revenue will be around 4,000. So then the profit will be 4,000 minus 2,100 equal 1,900. You notice now the profit is bigger. At that point, when the firm is producing 1,000, the profit is bigger. We have the biggest difference between the total revenue and the total cost. There will be another form to get this maximum profit, but this is the idea, to get the point where we have the biggest difference. Remember, this firm is producing in the market when the price is 4. Remember, all this total revenue was computed when the price was 4. From this, we conclude that this firm is producing 1,000 units, because at that point we have a maximum profit. We learn from here that to study the profit maximizing output of a firm, we need to take into account the cost. So we need to study the cost of the firm. Let's study the cost of this firm. For doing that, we need to have quantities produced, so in this, remember that the quantity here is in hundreds, and the total cost. We have here the points and we have here the schedule. This graph actually was taken from this schedule of the firm. To study the cost of the firm, it will be good to take into account the total cost divided by the quantity produced. So for example, here in the second row, the total cost was 10 and the quantity was 1. The total cost in this case is 10. But here the total cost changed, the average total cost changed, because here the total cost is 12 and the quantity produced is 2. So here we'll have 6, the average total cost in this third line. In the first line we cannot compute the average total cost because this is 0 here. So if we make a schedule of the average total cost, the answer will be like this, average total cost. So here 10, here 6, 13.5 divided by 3, 4.5, and in any case is the total cost divided by the quantity. For example, in this 14.5 divided by 5 in this line when the company is producing 500. So this is the average total cost. From this graph, we notice that this 7.5 need to be the fixed cost of the company. Because when the company is not producing anything, they have a cost, 7.5. So another thing that we learn from this graph, from this schedule, is that the total fixed cost will be 7.5. And this will be easy to notice in a schedule because we notice that will be the point for which the quantity produced is 0. So that will be the total cost. And obviously we know that the formula of the total cost is the total fixed cost plus the total variable cost. The firm have two kinds of costs, the fixed cost and the total variable cost. And we have here the fixed cost was 7.5. Then we can compute the total variable cost. Because now we know the total fixed cost, that is 7.5. In case that we want to compute the total variable cost, so the total variable cost will be just the total cost minus the total fixed cost. And from this total variable cost, we can compute the average variable cost. Because remember that the average variable cost is the total variable cost divided by the quantity. Remember, to compute the total variable cost will be the total cost minus the total fixed cost. For example, here in the second line, the total cost is 10 minus the total fixed cost is 7.5. 10 minus 7.5 will be 2.5. So the total variable cost will be 2.5 divided by 1 will be 2.5. So the average variable cost when producing 1 unit will be 2.5. In the second, we have 12 is the total cost. Total cost minus 7.5, that is the total fixed cost. 12 minus 7.5, it will be 4.5. 4.5 divided by 2 2.25, that give me the average variable cost when the quantity produced is 2. So we can make this schedule of everything. Notice here, for example, in the fourth row, the 13.5 minus this 7.5. This is 6. This minus this, total cost minus total fixed cost. 13.5 minus 7.5, 6. 6 divided by 3 is 2. And you can do the same in every of them. 14.1 minus 7.5 and then divide by 4. 14.5 minus 7.5 and divide by 5, etc. And you are going to get these numbers. So in this way you can also notice if you have the total cost from the beginning, you can get the average variable cost of the firm. By the way, notice that the average variable cost at the beginning was 0 because you need to divide it by quantity. The quantity in this first row is 0, so you cannot get the average variable cost. If you are getting the marginal cost, okay, it's the change, they will be in between lines. This, for example, the change from 7.5 to 10 of the total cost is the change of the total cost, 2.5 divided by 1, because this is the change in the quantity demanded, 1. By the way, it's 100, but the change is from 0 to 100 is 100, but here will be also in 100. You can say 7.5 100. This will be 2.500 divided by 100, it will be 2.5. The 100 will be cancelled. So again here the change in the second change will be from 10 to 12. The marginal cost here will be the change in the total cost divided, that will be 1.5 divided by 1, it will be 1.5. Anyway, we can make another schedule for the marginal cost, and that gives me something like this. So you can see that this is correct. This will be the marginal cost for this firm. So if we have the total cost, we can get the average total cost, the average variable cost, and the marginal cost. And the reason why I'm doing this is because we are going to study this from another graph. So we study the maximum profit taking into account the total revenue and the total cost. But I want to use the other graph. Remember, in the previous slide, we have the relation of the price and the quantity produced by the company. The price, the marginal revenue, the marginal cost, the average total cost, the marginal cost, all of them will be in dollars per unit. So let's see what happened in this case. We have here that this is the marginal cost, the average variable cost, the average total cost of the company. And we also have a graph in which we have the demand curve of the firm. And I know that the demand curve will be a horizontal line. This is actually the marginal revenue, the average revenue, and the price at any quantity of output. And we can study what happened when we put the other graph that also are in dollars per unit. So we can make here the graph, for example, of average total cost, of the average variable cost, of the marginal cost. And you can see here the numbers, and you can make a graph. So you can make a graph. For example, for the average total cost is this graph. Remember, all this curve has a U shape. They are concave up. And you notice, for example, here that the average total cost, when the quantity is 1, the average total cost was 10. It's not here in the graph. And when the quantity was 2, the average total cost was 6. Was 6, this point here. When the quantity is 3, the average total cost was 4.5, 3, 4.5, etc. You can notice that this graph is actually made from this schedule. So we have this. We have also that the average variable cost, if we use these numbers here and we make the graph, it will be like this. So again, U-shape. And you notice that this curve is making from here. When the quantity was 100, the average variable cost was 2.5. The quantity is 1 and the average variable was 2.5. When the quantity was 200, the average variable cost was 2.25. So etc. So this is actually the average variable cost. Another one will be this marginal cost. Now we notice that this 2.5 is between 0 and 1. So this number here, 0 and 1. The value is 2.5. Between 1 and 2, between 1 and 2, I want to say 1.5. The marginal cost is 2. 1.5, the marginal cost was 2. So making this graph, we're going to have something like this. So this will be the marginal cost, another graph that is U-shaped. So this is the marginal cost. And from here, we are going to study what is the profit maximizing output of the firm in a perfect competitive market. We can do the same that we were doing before, yeah? So we can see that because the total profit is the total revenue minus the total cost, and we know that the total revenue is the price times the quantity, and the total cost, the average total cost times the quantity. So we can say that P multiplied by Q minus the average total cost multiplied by Q will be the profit. And the reason I'm typing in this way is in case that we have this value, instead of having total revenue and total cost, we have the price and we have the average total cost. So we have this type of graph that relates this variable here, the marginal cost, the average total cost, the average variable cost, and the price. And here obviously Q is a common factor, so we can type this as P minus average total cost multiplied by Q. So we can take out Q as a common factor. So P minus the average total cost and multiply by Q. Let's see what happens if Q equal 800. If the film produces 800, I can type here 800. So if the film produces 800, I'm in this point of the graph, 8. I know now that at that point, the price is 4 always, but the average total cost is 2.03. So we're going to have then that is 4 minus 2.03 multiplied by 800. So if they are producing 800 units, then this will be the profit. 1,576. You can use your calculator for doing that. And we can compute this in any other level of output. For example, what happens if the film produces 900 units? If the film produces 900 units, then I can substitute the quantity by 900, but at that point of 900, the price is always 4, but the average total cost, 900, the average total cost is 2. So it will be 4 minus 2 multiplied by 900, and this is 2 multiplied by 1800. So this is now the amount received, the profit received if the company is producing 900. And etc. We can see other points, 1,000 units. And I believe that was the biggest one, the largest profit that we decided before. Let's see again what happened. So it will be 1,000 Q, and this 2.10 will be the average total cost when they are producing 1,000, 10 hundredths. It will be 2.10, the average total cost. And in this case, we have 1,900, the profit. And if we produce more than this, 1,100, now you notice that at 1,100, the average total cost is 2.36, and at that point you are earning lower, so the profit is lower. It's better to produce 1,000 than 1,100 units. If the film produces 1,200, again 1,200, it will be 1,200, the average total cost is 3, and then it will be 4 minus 3 multiplied by 12, and this is 1,200, and again you are getting lower profit. Definitely, the biggest profit happens when the amount produced is 1,000 units. So we can make this type of work, but it will be again a lot of work. We are working a lot. Why we don't think a little before starting working? So let's see. The firm will try to maximize profit. And let's see what happens if the marginal cost is bigger than the price. So remember, the price is the marginal revenue, is the revenue I'm going to get from selling 1 unit more. If the marginal cost is bigger than the price, and the marginal cost is the cost that you have in the next unit that you are going to produce, you are not going to produce this unit. This is a point of no equilibrium for the company. If the company is working in a point when the marginal cost is bigger than the price, the company is going to try to produce less, because this point is giving you more cost than the revenue, because the revenue, remember, the marginal revenue is the same price, so the revenue you're getting is lower than the cost. So this is not the point of equilibrium. The company is going to try to produce less than this. What happens is the opposite, if the marginal cost is lower than the price. So imagine that if you produce the next unit, you are going to get more revenue than the cost. Your profit is going to increase. So if the company is in this situation, that is good that the revenue is bigger than the cost, but then the company is going to try to produce the next unit because the next unit is going to give more revenue than cost. So this again is not a point of equilibrium. The firm will try to produce more if they are in this situation. The only situation when the firm is happy that it stopped working is the only one that is missing here, because there are three possibilities: marginal cost bigger than price, marginal cost lower than price, and the other one will be the marginal cost equal price. So the first produce the output for which the marginal cost equal price, and this is it. So this will be the point of the maximum profit. So this is the way that we analyze this type of situation. And if the marginal cost equal price, and this first means this is the marginal cost curve, the yellow one that you see here, the price is this, and they are the same at that point, the intercept of that point. So this point give you is happen when you are producing 1,000. So the same value that we obtained before, but now without not so much work. So this point here, the intersection of the marginal cost and the demand curve will give you the point of maximum profit. And if you are working a problem like this to determine how much the firm is producing, what you need to do is just find this point of intersection and then go down to see how much the firm is producing at that point. And at that point, when the marginal cost and the price is the same, the company, in this case, is producing 1,000. So for this example, the profit maximizing output is 1,000, so it will be 1,000. So in this case, the price in the market, remember, is $4, and this company produced 1,000 units. And if you want to know what is the maximum profit, then get the area between the price and the average total cost at that point, because the company is producing 1,000, so 1,000, so 1,000 units, so the average total cost will be this, and this area will give you the economic profit. So this will be the economic profit if the price is $4. What happened if something happened in the market and the price change? For example, what happened if the price is 2.5? So 2.5 is this point here, 2.5. And now, how to see what is the profit maximizing output? Okay, will be the point in which the marginal cost and the price intersect. It will be this point here. The company produced 900 units. And then this will be the average total cost, and then the profit will be lower. The firm is a price taker, and if the price in the market is 2.5, then the company produces 900. It would need to produce lower, and always this will be the economic profit at that point, this area here. And you know that this is smaller. So the profit could be changed if the price changes in the market. For example, if the price in the market is 1.90, and we need to find the point of intersection between the price and the marginal cost. So the company is going to produce an amount like this, 8.500, so 850 units. And the profit, remember the profit, you need to take into account the average total cost. So in this case, the marginal cost, the average total cost, and the price, the three of them intersect at that point. So at that point, there is no rectangle here, so at that point, the profit is zero. So the economic profit is zero when price, marginal cost, and average total cost are the same. If the price goes so small, in such a way that the marginal cost, the average total cost, and that price intersect in the same point, then at that point, the economic profit is zero. And this economic profit zero doesn't mean that the company doesn't have accounting profit. Maybe there is accounting profit, but this is the economic profit. The economic profit will be zero for the company. Let's analyze now what happens if the price is so low as $1.10. If the price is $1.10 and we want to decide how much this company need to produce, we know that we need to see the price and the intersection of this demand curve that we know that is horizontal, the point of intersection with the marginal cost. So the number of items that need to be produced, it will be around 760. Let's take note of this. So the company produces 760 units. And you notice also that at that point, we don't have only the price and the marginal cost intercepting, but also the average variable cost. Remember that the marginal cost intercept the average variable cost in the minimum of the average variable cost. At this point, the price is exactly the same of the average variable cost. So the price, the marginal cost, and the average variable cost will be the same at that point. And because the price is exactly the average variable cost, we say that the company is just covering the average variable cost. If the price go a little lower, then the company is not able to cover its variable cost. So that will be the shutdown point of the company. And obviously at that point, the company is having an economic loss. Look at here that the average total cost is over the price. So this area here is now, because the average total cost is at the top, average total cost minus the price, it will give you the economic loss. So we are going to have a negative profit. Remember, to get the profit, you need to subtract price minus average total cost and multiply by the quantity that gives you the area of this rectangle. And in this case, it will be negative. So we have an economic loss. And this will be the shutdown point for the company. If the price is so low as it's just covering the average variable cost, that will be the shutdown point for the company. So we say the economic profit is negative and the shutdown point occurs when the price, marginal cost, and average variable costs are the same. And that happens exactly at the point of the minimum average variable cost. It's just that the price is so low that it covers only the variable cost. What we have done so far is important because we show a relation between the price in the market and the quantity that the firm is producing. So far, this curve that we have is the demand curve, but now we have a relation between the price and the quantity produced by the firm. So we know that the firm produces the quantity such that the marginal cost and the price is the same. If we are going to analyze the relation between the price and the quantity that the firm is willing to produce, then what we're having is a supply curve. So from here, we can conclude what will be the supply curve of the firm. The supply curve shows the relation between the price and the quantity produced, the quantity the company is willing to produce. Let's see, we have several prices, 1.10, 1.50, etc. And if we know the price, we can get what is the quantity produced easily. For example, if the price is 110, and actually we get this 110. If the price is 110, we go here 110 and see what is the intersection between the price 110, that will be a horizontal line, the demand curve, 110, and this marginal cost. Go down and find what is the quantity produced. And I noticed that is 760, around 760, 750. Let's type here 760. So the quantity produced is 760. So let's see what happens if the price is 150. So the price is 150, go and see what intersect with the marginal cost. That give you then the quantity produced. So the quantity produced at that point going down from the point of intersection. So this is the point of intersection going down, and it's around 810. So let's try here 810. And let's see what happens if the price is 190. If the price is 190, again we go here with the intersection point, and this intersection point with the price and the marginal cost produce an amount here like 850, and this will be a point that show me the relation between the price and the quantity produced. When the price is 190, the company is willing to produce 850. Let's type here 850. And then we are making the supply curve. And if you notice, the supply curve are always pointing the marginal cost. So we have, for example, if the price is 2.50, so this point here, 2.50, we intersect with the, and I noticed that is a little more than 9, yeah? A little more than 900. So when the price is 250, we have this point. And again, it will be a point in the marginal cost. We see then that always to get the relation between the price and the quantity produced, what we need to see is the marginal cost. So for example, if the price is 3, the quantity produced will be more than 900, around 940. So it will be here, this will be the point that show me the relation between the price and the quantity produced. Let's see, 940, etc. So we notice then that the marginal cost is giving me the relation between the price and the quantity produced. So this will be the same supply curve then. We can continue giving all these points, and we notice that obviously the points will be points in the marginal cost, and this will be also the points in the supply curve, because the supply curve is what shows me the relation between the price and the quantity produced. So for example here 4.50, if I want to know what is the quantity produced, I need to go to the marginal cost again, and I can continue doing the same, and I will need to find the points in the marginal cost curve to find the quantity produced. From this we conclude that the marginal cost is the same supply curve for the firm, and it's the same supply curve from the shutdown point. And remember, the shutdown point is the minimum point of the average variable cost. It will be the point when the marginal cost and the average variable cost intersect. So at that price is the first price when the firm is selling something, is producing something. If the price go down, the firms will be outside of the market. So the supply curve will look like this. We can say then that a competitive firm supply curve is given by the portion of its marginal cost curve that is above its average variable cost curve. And what happened with the market? Because we know how to compute the supply curve of a firm. And when we have another firm, we can get the supply curve in the same way. But if we want to know the supply curve of the two firms, we'll be adding together the outputs. For example, if the price is 1.5, this company is producing 800. And when this price is 1.5, this company is producing 4. So when the price is 1.5, the two companies together are producing 8 plus 4. So it will be 12. So this will be the amount produced for the two firms together, adding together the two amounts. Or for example, when the price is 6, the first company is producing 1100, the second company is producing 9,500. So I need to add together the two outputs to know what happened the two firms together when the price is $6. So actually a curve of the supply curve of the two firms will be the sum. So adding together the outputs, obviously. Adding together the supply curve of all the firms is going to produce the whole supply curve of the market. In perfect competition, the industry supply curve is the horizontal sum of the marginal cost curve, remember, above the level of average variable cost of all the firms in the industry. We have studied what happened to a firm in a perfect competitive market, at least at a short run. So when the time frame is not so long. So how to study this in the long run? What is happening with this perfect competitive market? So we know that if existing firms are making positive economic profit, so then it will be easy for new firms to enter the industry. New firms have an incentive if that happens, if they see that there are positive economic profit. If existing firms are making zero profit, there are no incentive for new firms to enter and no incentive for existing firms to exit. So there will be like a point of equilibrium of the number of firms. And finally, if existing firms are making economic losses, there is an incentive for existing firms to exit the industry. So some of them that they are not covering the average variable cost, they will be leaving the industry. And what happens when there is this type of movement in the market? We know that we have a supply and demand curve, and this supply and demand give me an equilibrium point. This equilibrium point is the one that determines the price of the market and the quantity exchanged in the market. If there is positive economic profit, then there will be new firms that will try to be into the market. And that gives me an increase in supply. And we know that there is an increase in supply, the market supply curve will be shifted to the right. So it will be this, for example, if we have this supply curve can move this way. But what happens if the supply curve moves this way? Then the price in the market will be different. Yeah? So the price in the market go down. So this is new price. The price falls and then the entries stop when all firms are just covering their total cost. If they continue making profit, new firms continue going into the market, and again the supply curve start moving. This situation will stop when the firms are covering the total cost. So there is a zero economic profit. So if we see this in a different direction, if the firms are experimenting economic losses, then some firms will gonna try to leave the market. It's easy to exit the market. Remember, this is a perfect competitive market. And what firms will be leaving the market? The firms that are not covering the average variable cost. So exit leads to a decrease in supply. The market supply curve shifts leftward. And that means that there is an increase in price, yeah? Because now the price was here, for example, around 60 in this graph, and now it's a little bigger than 80. So if there is a shift of the supply to the left, there is an increase in the price. And this exit stops when all the firms are just covering the total cost. So obviously, if the price rise so much that now the firms are getting profit, then another firms coming into the market, and then the situation that I explained before happens. So the only equilibrium situation point when all the firms are having zero economic profit. Of course, for a firm, we can study the situation if we use the long run average cost. So the long run average cost, remember, is a curve like this and show what is the cost of the firm at the long run. In the short runs, so for example, if the quantity produced is Q0, let's see when the firm have an economic profit 0 at the short run. Remember, at short run, the firms only can change one factor of production, maybe labor, for example. What is happening is this: the marginal cost is here, this is the intersection with the price, and at that point, the price is the same to the average total cost. So that means that the profit is 0. But it's 0 at the short run. The company could do something. So actually, the long run is a study what happened to the firm if they can change other factor of production. They can, for example, increase the number of plants. So this curve is giving more information what is happening at the long run. So at Q0, at that point, the firm is maximizing short run profit, but not its long run profit. So the company can work in such a way that change other factor of productions, and obviously the short run curves could be different. But this is, by the end, the smallest point that they can achieve. Remember the point when, at the long run, the average total cost is the minimum efficient scale. After that point, the company cannot do anything. So anyway, when they achieve this situation, increasing capital, yes, more plants or whatever, so it will be anyway a point that's going to happen. So in the long run competitive equilibrium, each firm is operating at the minimum point of its long run average cost curve. And at that point, the firm is maximizing profit. At that point of time, the firm is maximizing profit, but cannot do any other thing, cannot be working in another point in which the average total cost is lower. So that will be a point that have the minimum cost. So in the long runs, so we are going to have some situations. First, existing firms are maximizing profit, and the short run marginal cost of productions equal the market price, and we can see this here. Second, the economic profit for each firm is zero. And third, existing firms are not able to increase their profits, so they are not able to increase their profit. And again, we can see this in the graph. There is no way here they can increase their profit. Moving to the right in this curve is going to increase the average total cost. Moving to the left is going to increase the average total cost. That will be the equilibrium point of the market. All the firms will be having zero profit, and they are going to be working in the minimum efficient scale. So the point of minimum output when you are getting the minimum average total cost. So this point here, that's the minimum efficient scale. The previous short runs equilibrium were obtained in this part. So the firm was always working in this part of when there was a part of decreasing cost or increasing return. So anytime that was moving from one point to another, the firm was increasing return. At the other portion of the long run average total cost, the firm is not going to work. At that point, there will be an increase of cost, and there will obviously will be a decrease of return. So that will be the point or the condition for long run equilibrium. And that finished my presentation today. Thank you.